Coulomb's law. So under Coulomb's law, there are only two things you need to understand. The first one is going to be the principle or the law. Coulomb's law itself, you need to understand the concept of Coulomb's law itself. Two, you need to understand the concept of superposition principle. Superposition principle. So you need to understand under Coulomb's law, you need to understand the concept of Coulomb's law itself. We are going to understand also superposition principle. So let's get started with Coulomb's law. So Coulomb's law. Okay. So what does Coulomb's law state? Coulomb's law states that the electrostatic force between two point charges directly proportional to the product of the two charges, and inversely proportional to the square of their separation distance, So Coulomb's law states that the electrostatic force between 2 point charges is directly proportional to the product of the two charges and inversely proportional to the square of their separation distance. The mathematical proportion means force, that is electrostatic force, is directly proportional to square, directly proportional to the product of two charges, charge 1, charge 2, and inversely proportional to the square of their separation distance r. So this is in a case where you have a charge here 1 and another charge here 2, and the separation distance, in this case I'll name it r. So it's saying that for you to find the force, or for you to find the amount of attraction or repulsion that is occurring between these two charges, you need to multiply the size of each charge and also divide by the square of the separation distance. So this is a proportion. So when you convert the proportion to the actual formula of Coulomb's law, it's going to be force is equal to, we're going to introduce a constant called K, and we're going to say charge 1 and charge 2 over square of their separation distance. Okay, so charge 1 should have an SI unit of Coulomb. Charge 2 should have an SI unit of Coulomb. The distance r squared should have an SI unit of what? Meter. SI of what? Meter. That means force. The SI unit of force is going to be Coulomb per meter squared. So those are the SI units that we have. Force is Coulomb per meter squared. Distance is supposed to be in meters. Squared. It is supposed to be in meters squared, meaning n squared. Like that. Then charge 1 is supposed to be in coulombs. Charge 2 is supposed to be also in what? In coulombs. and force is supposed to be in Coulomb per meter squared. So if you understand that, we also need to come to understand the constant K. So the constant K, the value of the constant K is equal to 1 over 4 pi epsilon naught. Okay, so maybe before you even understand the parts of a constant K, what is the constant K? Okay, understanding the constant K. The constant K represents the permittivity, okay, permittivity of material. Permittivity of material in which charges are observed. Okay, so constant K represents the permittivity. So permittivity means how much electricity that the material in which the charges are being observed can conduct. Okay, so we know the value for is a constant. Pi is 22 over 7. Pi is 22 over 7. Then the value of epsilon, this symbol is called epsilon. Okay, epsilon naught. So when it's written like this, it is in small letter. Okay, this is small letter of epsilon or lowercase letter. In capital letter, it will be written as a capital E like this. So in other books you might find this symbol. In other books you might find this symbol. They both stand for epsilon naught. So epsilon, okay. So epsilon follows that the same way K represents the permittivity of the material. Epsilon represents also the permittivity of the material. Okay, this is permittivity of material. Permittivity of material. Which charges are what? Which charges are observed. So every material in which charges are placed is going to have a different permittivity value. But if you see an epsilon naught with a 0 here, this means it's the permittivity of what? Of free space or a vacuum. So this is permittivity of free space. If you just see a random epsilon without a naught, it means it's a different type of material, not knowing whatever material it is, but in most cases the book will indicate for you what material it is, or if you ask questions will indicate for you what that material is. So the value of epsilon naught is equal to 8.85 times 10 to the power negative 12, like that. Coulomb squared and m minus 2. Okay, so you can either use this value for epsilon naught, it's okay, or if you don't want that value, you can still use 8.98 times 10 to the power 9 nm squared c minus 2 to the power minus 2. You can use that value if you don't want the first one. If you don't want to use these two values, you can also use, sometimes epsilon is given the value of force is equal to 9 times 10 to the power 9 n Coulomb to the power minus, or sometimes the value of epsilon is equal to 9 times 10 to the power 9 charge 1 charge 2 over r squared. So I know the values for epsilon are multiple, but most often in most books you're going to see this value, but you can choose which one of them that you want. So in some books you might see this value being used is to the value of epsilon, the value of epsilon naught at free space. In some books you might see this value being used, it's one and the same thing. So you just get the value that you're comfortable with for calculation. So in most of my calculations I'll be using 8.85 times 10 to the power negative 12. So epsilon naught at STP is given a value of 1.00 epsilon naught. Okay, so that is what you should understand about the principle of Coulomb's law. So getting back to the formula or principle of Coulomb's law. The formula of Coulomb's law is equal to force is equal to K, charge 1, charge 2 over R squared. SI unit is going to be Coulomb per meter squared. So there's something you should understand about Coulomb's law. So Coulomb's law can only calculate force of attraction or repulsion between two charges. So Coulomb's law is limited. Okay, take note of this. Coulomb's law is limited to calculating force, calculating force between two charges. So Coulomb's law can only be used to calculate force between two charges. But however, we should understand that there is an infinite number of charges in the universe. Therefore, Coulomb's law is not really applicable for real life situations if you want to do actual calculations in science. So this is where the principle of superposition comes in. But however, this is all you're supposed to know about Coulomb's law itself. In the next video, we'll start talking about the principle of superposition. So Coulomb's law is electrostatic force between 2 point charges. Coulomb's law states that the electrostatic force between 2 point charges is directly proportional to the product of the two charges and inversely proportional to the square of the separation distance. This is the proportion here, and this is the formula. The components of the formula for both charges must be in the unit of Coulomb, and then the R must be in the unit of, or the distance separating the charges must be in the unit of meters, and force must be in Coulomb per meter. Epsilon naught is there, the value of the constant K is there. Another thing to understand about Coulomb's law, sometimes your values are not going to be given to say maybe a charge has a size of, let's say, for instance, 2 Coulomb. This is just 2 coulombs. But let's say sometimes you'll be told your charge has got a size of 2 microcoulombs. Okay, so the value of micro is equal to 10 to the power negative 6. So not the value of what? Not the value of a micro. So in that case, if you are substituting this value into an equation of Coulomb's law, you're going to say 2 times 10 to the power negative 6. So 2 multiplied by what? Multiplied by the value of micro. So it's important to note these details because in most books that you're going to be studying, you're going to be finding the value of micro. So this, you can proceed to watch the video on superposition principle.